the ratio of dimensions of Planck's constant and that of moment of inertia has the dimensions of. Planck's constant is Joule second. Moment of inertia is kg meter square. Joule is kg meter square per second square into second divided by kg meter square. Kg meter square get cancels. These two gives per second. Per second is same as the frequency. Time, frequency, velocity, angular momentum. Frequency. The velocity time graph of two bodies A and B are shown. Then the acceleration of A and B are in the ratio. Velocity time graph, slope gives acceleration. Slope gives acceleration. Okay. And slope is tangent of this angle. Therefore, acceleration of first by acceleration of second equal to angle made by A with respect to x-axis is 25 degree. 25 degree. Tan 25 by tangent of this angle. This angle is given 40. Total angle is 90. Therefore, this is 50. It is tan 50. So ratio tan 25 to tan 50. Tan 25 to tan 50. A particle is projected with a velocity v so that its horizontal range is twice the greatest height attained. Expression for height is given by u square sine square theta by 2g. U square sine square theta by 2g. Height is maximum only when sine square theta is 1. Therefore, greatest height is u square by 2g. And they are asking range. Range equal to twice the greatest height. Greatest height is u square by 2g. Therefore, range r equal to u square by g. In this case v, therefore v square by g. A stone of mass 0.05 kg is thrown vertically upwards. What is the direction and magnitude of net force on the stone during its upward motion? Upward motion or downward motion? If this is the stone, then direction of force is always down and it is equal to m into g. M is 0.05, g approximately 10, product of these two 0.5, downward, vertically downward 0.09, closer to this. The kinetic energy of a body of mass 4 kg and momentum 6 Newton second will be kinetic energy in terms of momentum. Kinetic energy equal to p square by 2m. Momentum is 6 into 6 by 2 into mass is 4 kg equal to 2, 3, 4, 1.5, 4.5. The ratio of angular speed of second hand to hour hand of a watch. Angular speed is given by theta by t, which is omega. Angular velocity, angular speed. Angular speed of second hand. Angular speed of second hand by angular speed of hour hand. Second hand takes 60 seconds to complete one rotation. One rotation is 2 pi. Hour hand takes 12 hours. 2 pi by 12 hours, 1 hour is 3600 equal to 2 pi get cancels, 61, 60, 60, 60 into 12 goes to numerator, 12 hourly 72, 720 is to 1. 720 is to 1. If the mass of a body is m on the surface of the earth, the mass of the same body on the surface of the moon, it is m, because mass remains same everywhere. Only weight changes. With respect to acceleration due to gravity, weight changes, but mass remains same. Moment of inertia of a thin uniform rod rotating about the perpendicular axis passing through its center is I. If this is a thin rod about this axis, if the rod rotates, then moment of inertia is given by m L square by 12. This is a standard equation. If same rod is bent into a ring and its moment of inertia about its diameter is I dash, the same length is bent into a ring. If it is bent into a ring of radius r, then total circumference is L. So we can write 2 pi r equal to L. Therefore radius equal to L by 2 pi. And if this is the ring, moment of inertia about its diameter means it is half m r square, which is equal to half m r square is this square, L by 2 pi square. This is nothing but I dash. So moment of inertia of the rod to moment of inertia of the ring equal to, this is ml square by 12 divided by half m L square by 4 pi square, L square by 4 pi square. ml square get cancels, 4 1, 4 3, this pi square goes to numerator, 2 pi square goes to numerator, so it is 2 pi square by 3. 2 pi square by 3. The ratio of hydraulic stress to strain is modulus of elasticity. Hydraulic means bulk modulus related to volume. Therefore, bulk modulus. The efficiency of Carnot's heat engine, which operates between two temperatures, is efficiency equal to 1 minus T2 by T1, 1 minus Q2 by Q1. Okay. This is always related to source. Bear in mind, don't get confused. Source. And this is for the sink. Okay. So it is efficiency equal to 1 minus T1 temperature of source 500, temperature of sink 300. 1 minus 3 by 5 is 2 by 5, which is equal to 0.4. 0.4 is 40%. Water is heated from 0 to 10 degrees Celsius, its volume, 0 to 10. So in the case of water, a graph of volume versus temperature in degrees Celsius. First volume decreases with heating and then volume increases. This is called anomalous expansion of water, you know. And water is minimum, volume of water is minimum at 4 degrees Celsius. Therefore volume first decreases and then increases. First decreases and then increases. In the same question, if density is asked, density equal to mass by volume. So density is inversely proportional to volume. If volume decreases and then increases, the density should first increase and then decrease. And density is maximum at 4 degrees Celsius. 1 gram of ice is mixed with 1 gram of steam at thermal equilibrium temperature of the mixture is. It's a standard result. 1 gram of ice is mixed with 1 gram of steam. If these two are mixed, latent heat of steam is more, very much greater than latent heat of ice. If these two are mixed, then ice will melt, becomes water. Still the heat energy is sufficient. Heat energy from the steam is sufficient to heat the water. So ice becomes water, water can be heated, and water starts boiling at 100 degrees Celsius. Okay. What is the standard result means? If equal amounts of ice and steam are mixed, steam means here 100 degrees Celsius, ice means 0 degrees Celsius, then the resultant will be water at 100 degrees Celsius. So this is 100 degrees Celsius. The ratio of kinetic energy to the potential energy of a particle executing simple harmonic motion at a distance equal to half of the amplitude. Distance equal to a by 2. We have to find at this. Measured from its equilibrium position. From its equilibrium position, we are on safer side. We can use all the formula. Okay. Kinetic energy is given by, kinetic energy is half k a square minus x square. And potential energy is given by, potential energy half k x square. Ratio of kinetic to potential means this. So half k get cancels. A square, displacement equal to half of the maximum means a by 2 its square, x square. A square by 4 by x square is a square by 4 equal to. A square can be seen everywhere. So this a square get cancels with these two. 1 minus 1 by 4 is 3 by 4, 1 by 4. So this is equal to 3:1. 3:1. When two tuning forks A and B are sounded together, 4 beats per second are heard. The frequency of B is, this is B. Frequency of B is 384. So for A, possibilities are 388 and 380. Since beat frequency is 4, add 4 to this 388, subtract 4 from this 380. So difference of these two is 4, difference of these two is also 4. So these two are the possibilities for A. Okay. When one of the prongs of A is filed, filing increases the frequency. Okay. So A is filed, so frequency of A increases. This also increases. There are two possibilities. Let us assume this also increases, this also increases. Then the beat frequency increases. By filing, beat frequency increases. It is given 388. Suppose this 388 has become 389. What's the difference of these two? 5. What is the difference of these two? 5. Earlier it was 4, now it is 5. Suppose if frequency is 390, then difference of these two is 6. See, if we assume that frequency of A was 388, after filing, bit frequency increases, means 388 is the answer. Now assume 380 is the answer. This is the answer, but assume that if this is the answer, what would have happened? If 388, after filing, if this becomes 381, difference of these two is 3. Suppose if it is 382, difference of these two is 2. See, the beat frequency is decreasing. It is given beat frequency increases. Therefore, earlier frequency is 388. The question supposed to be, Then the frequency of the fork A before filing. Before filing it is 388. A stretched string is vibrating in the second overtone. Second overtone is third mode. Third mode means there should be 3 loops. 1, 2, 3. Rigid support, rigid support. Then the number of nodes and antinodes between the ends of the string. These are the nodes. There are 2 nodes and these are antinodes. Antinode. Nodes and antinodes. 2 nodes and 3 antinodes. 2 nodes and 3 antinodes. 2 spheres carrying charges 6 micro, 9 micro, separated by a distance d, experience a force of repulsion F. Repulsion because both are positive, like charges. When a charge of minus 3 microcoulomb is given to both the spheres and kept at the same distance as before, the new force of repulsion is, force is constant Q1 Q2 by R square. Okay. Now concentrate on only these two. Force is directly proportional to product of the charges. So force is proportional to product of the charges. Initially 6 and 9 micro, 6 and 9 micro, enough. Now minus 3 is added to both. New force is proportional to, if minus 3 is added, 6 minus 3 is 3. First charge is 3. Then the second charge, 9 minus 3 is 6. Second charge becomes 6. Separated by the same distance. Then the new force of repulsion is, divide one by the other, 6, 3, 1, 3. So F dash equal to F by 3. Pick out the statement which is incorrect. Tangent drawn to a line of force represents the direction of electric field. Yes. Electric field lines forms closed loop. This is incorrect. Therefore, this is the answer. A negative test charge experiences a force opposite to the direction of electric field. True. If this is the electric field, positive charge experiences force in the direction of the field, whereas negative charge experiences against. Field lines never intersect. That is also true. Second is the incorrect statement. The angle between dipole moment and electric field at any point on the equatorial plane is 180 degree. Standard result. Meaning, if this is plus q, this is minus q, this is a dipole, this is the equatorial plane. Because of positive charge, electric field is away. Because of negative charge, electric field is towards. Resultant electric field is, this is the resultant electric field. What is the direction of dipole moment? Dipole moment is always from minus q to plus q along the line joining the charges. So this is the direction of dipole moment. And these two are in opposite directions, means 180 degree. 3 point charges, 3 nano, 6 nano, 9 nano, are placed at the corners of an equilateral triangle. Equilateral triangle, 3 nano, 6 nano, 9 nano. Length of each side is 0.1 meter. 0.1 meter. Potential energy of the system is, potential energy of 3 point charges is constant Q1 Q2 by R1, Q2 Q3 by R2, Q3 Q1 by R3. Okay. constant is 9 10 power 9. All distances are equal. 0.1 meter means 10 power minus 1. Q1 into Q2. 3 nano into 6. 6 into 3 is 18. First charge is nano, second charge is also nano. All of them have 10 power minus 9, 10 power minus 9 common factor. 6 into 3, 18 plus 9 into 6, 54 plus 9 into 3, 27. These two get cancels, minus 9 plus 9. Minus 9 by 10 power minus 1 is 10 power minus 8. This is 9. Sum of these three gives some other number. It's a very small number, but they have given wrong options. Therefore, grace is awarded. A spherical shell of radius 10 centimeter. This is a spherical shell which is charged. Radius is 10 centimeter. If the electric potential at 5, 10, 15. 5 centimeter means inside the shell potential is V1. On the surface V2. Outside the shell V3. We know potential inside the shell is same as that on the surface. Therefore, V1 equal to V3, V2. And with the increase in distance, potential decreases. Meaning, influence of the shell, influence of the charge decreases with distance. Therefore, these two potentials should be greater than V3. V1 equal to V2 greater than V3. Parallel plate capacitor is charged and then isolated. And here is the capacitor which is charged. Initially it is charged. Plus, minus. Okay. And then isolated. The effect of increasing the plate separation. If this distance is increased, effect of increasing the plate separation on charge. If separation between these two increases, charge remains same. Constant, constant, constant. Potential. If distance between these two increases, effect of one on the other decreases. And capacitance also decreases. Capacitance equal to epsilon naught A by D. With the increase in distance, capacitance decreases. So, capacitance decreases. So, this cannot be the answer. We have to decide between these two. With the increase in distance, effect of one on the other decreases. So, potential of the system increases. Why we are keeping second capacitor or conductor, second plate closer to first one? To decrease the effect, to decrease the potential. If distance increases, then potential of the system increases. Therefore, increases. 4 identical cells of EMF E and internal resistance R E are connected in series. Suppose if one of the cells is connected wrongly, means opposite, equivalent EMF. First cell, second cell, third cell connected wrongly means this is the only possibility. E, 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 E. These two are identical cells which contradict each other means this is cancelled by this. Therefore, resultant EMF is 2E. But internal resistance of each cell is R. There is no polarity for resistance. Therefore, it is 4R. EMF get cancels, but internal resistance remains same. Therefore, 2E, 4R. 3 resistances, 2, 3, 4 are connected in parallel. Fine. 2, 3, 4. They are in parallel. 2, 3, 4. Okay. The ratio of currents passing through them when a potential difference is applied across its ends will be. Resistors are said to be connected in parallel if potential difference is same. So V1 equal to V2 equal to V3. And potential difference is current into resistance, isn't it? Now, take first. This is induction method. Induction method means from options to the answer. We are going from options to answer. Okay. 6 into 2 is 12. 3 into 3, 9. 2 into 4, 8. These are not equal. We should get V1 equal to V2 equal to V3. So this is not the answer. Consider the second option. 6 into 3, 12. 4 into 3, 12. 3 into 4, 12. All the values are equal. This could be the answer. This could be the answer. 5 into 2, 10. 4 into 3, 12. 3 into 4, 12. See? 4 into 2, 8. 3 into 3, 9. Therefore, this is the answer. Two cells joined in opposition. R1, R2 be the internal resistance. Terminal potential difference is. Terminal potential difference means I into external R equal to. But current is equivalent of these two is, since this opposes this, E1 minus E2. Total, this is the total EMF divided by 3 resistors in series, R1 plus R2 plus R. So this ratio gives total current into external is R. There should be difference. There should be difference with 3 values in the denominator. In the circuit, ammeter and voltmeter readings are 3 and 4. This is 3 ampere, 6 volt respectively. Then the value of the resistance R. 3. Product of these two should be equal to 6. Therefore, R should be equal to 3. Okay. But ammeter will have some resistance. This resistance plus this resistance should be equal to R. Means R is always less than 2. Less than 2. Look at the options. 2 greater than 2, less than 2, greater than or equal to 2 means you have to consider resistance of ammeter. This small value and then this. For example, resistance of ammeter is 0.2 ohm. Then resistance of the resistor is 1.8. Certainly 1.8 should be less than. In Wheatstone's network, PQRS 2223. The resistance with which S is shunted in order that bridge may be balanced. If you carefully see, all the values are equal except S. If this also becomes 2, then the bridge is balanced. To become 2, it should be shunted with means paralleled with 6. See, this is 3, this is 6, 6 and 3 in parallel means 3 into 6 by 3 plus 6 equal to 3 1, 3 3, 3 3, 3 2 times. So equivalent can be 2 only if it is 6. The resistance of the bulb filament is 100 ohm at 100 degrees Celsius. The resistance of a bulb filament is 100 ohm at 100 degrees Celsius. If its temperature coefficient of resistance is 0.005 per degree Celsius, its resistance will become 200 ohm at temperature. So temperature coefficient of resistance at some temperature is equal to resistance at 0 degree into 1 plus alpha T. Observe, this is small t means it is in degree Celsius. This is resistance at 0 degree Celsius. This is resistance at T degree Celsius. Okay, fine. Now resistance is 100 at 100 degree Celsius. 100 ohm R0 into 1 plus alpha is 0.005. 0.005 into 100. Second case, it should become 200. 200 resistance at 0 degree into 1 plus 0.005 into T. Now divide one by the other. This 2 times R0 get cancels. This is 2 equal to 1 plus 0.005 times T divided by 1 plus this 0.005 into 100 is 0.5, 1.5. 2 into 1.5 is 3 equal to 1 plus 0.005 T. This is 2 equal to 0.005 times T, or T equal to 400. Since it is small t, it should be degree Celsius. Two into 10, 2 equal to 0.005 T, therefore T equal to 400 small t degree Celsius. Therefore 400. Two concentric coils, each of radius equal to 2 pi centimeter, are placed right angles to each other. Means this is first circular coil, this is second circular coil. First coil gives magnetic field along the axis B. Second coil, that is this second coil, gives magnetic field along its axis B. Therefore resultant is always by the Pythagoras theorem, because they are perpendicular to each other. So resultant equal to root of B1 square plus B2 square. Okay. What is the magnetic field at the center of a circular coil? Constant 2 pi Ni by R. This is the formula. So resultant field is given by root of B1 square, B1 constant square 2 pi Ni by R its square plus B2 square constant 2 pi Ni by R square. First coil 3, second coil 4. Current through first coil is 3 ampere, second coil is 4 ampere. Okay. Now resultant magnetic field at the center. With little practice you can save many steps. Since it is root of two terms, take common factor. So resultant equal to, this constant is common factor, which is 10 power minus 7. 2 pi, 2 pi, 2 pi. N is 1, nothing is mentioned in the problem. Radius is given 2 pi centi is 10 power minus 2. Then root of remaining is I1 square and I2 square. I1 square is 3 square, I2 square is 4 square. 3 square plus 4 square is 5 square. Therefore 2 pi minus 7 minus 2 is minus 5. Minus 5. This gives 5. So it is 5 10 power minus 5 Tesla. A proton beam enters a magnetic field normally, means perpendicularly. Proton beam will describe a circular path. If the specific charge of proton is given, velocity, then radius of the circle described will be centripetal force is equal to QVB. Therefore, radius is equal to V get cancels, mv by QB. V by Q by M is called specific charge into B, equal to velocity is 10 power 9, which is nonsense, you know, because maximum velocity is 3 10 power 8. Due to just to solve this problem, they have taken it as 10 power 9 divided by specific charge is 10 power 11, magnetic field is 10 power minus 4. 9, 11, 2 minus 4 is minus 2, goes to numerator 2. So R equal to 10 power 2. It is 100. A cyclotron is used to accelerate. Cyclotron is a device used to accelerate charged particles. Neutron, no. Only positively, only negatively, both. A galvanometer of resistance 50 gives a full scale deflection of current 5 10 power minus 4 ampere. A resistance that should be connected in series with the galvanometer to read 3 volt is galvanometer that is connected in series. So galvanometer is connected into voltmeter. Galvanometer of resistance G is converted to voltmeter by connecting a high resistor in series. This is R. Current through the galvanometer is Ig. Remaining current is I minus Ig. Potential difference across them is same if they are in parallel. And expression for this resistance is R equal to V by Ig minus G. V is 3. Current required for full scale deflection is 5 10 power minus 4 minus 50. Simplify this. It is 5950. Two parallel wires 1 meter apart carry currents 1 and 3 respectively in opposite directions. Two straight parallel conductors in opposite directions means repulsive. We have to decide between these two. Force per unit length equal to constant 2 I1 I2 by R. This is mu naught by 4 pi. If it is magnetic field related, always mu naught by 4 pi, which is 10 power minus 7, 2. Two currents are 1 and 3, 1 into 3 by R. Distance between the conductors is 1 meter. 1. 3 to 6, 10 power minus 7. And then repulsive. 33. Direct question. If there is no torsion in the suspension thread, then time period of a magnet executing simple harmonic motion is. Whenever time period is involved, you cannot have 1 by 2 pi. 1 by 2 pi. Okay. So it is 2 pi I by mb is the answer. Standard question. Core of an electromagnet are made of ferromagnetic material which has high permeability. Core of an electromagnet should allow maximum lines to pass through. Okay, this is the core. So high permeability means mu, and very low retentivity. Low retentivity and low coercivity. These are the characteristics. Coercivity. So it is high permeability, low retentivity. Magnetic susceptibility of a paramagnetic material at minus 73 is 0.0075 and its value at minus 173. So susceptibility is inversely proportional to absolute temperature. Its value at one is minus 73 degrees Celsius, the other one is minus 173 degrees Celsius. Add 273 to this, it becomes 200 Kelvin, and this becomes 100 Kelvin. So this is 100 Kelvin. We want susceptibility. Susceptibility at 100. Susceptibility at 200 is 1 by 200 is 0.0075. Divide 2 goes to the numerator. So susceptibility equal to 2 times 0.0075, which is 0.015. Two coils have a mutual inductance 0.005. The current changes in the first coil according to the equation I equal to I maximum sin omega t. Maximum is 10 sin omega t. Omega is 100 pi. Beautiful. The maximum value of the EMF induced in the second coil is EMF induced due to mutual inductance is minus M into di by dt. So M is given, we have to find di by dt. So differentiate this with respect to time. Di by dt equal to 10 sin becomes cos 100 pi t into differentiate 100 pi t 100 pi. The maximum value means this should be maximum, and maximum value of cos function is 1. Therefore it is 10 into 100 pi. Therefore EMF equal to minus M 0.005 into di by dt is 1000 pi. 1000 pi equal to 1, 2, 3. It is 5 pi. If you consider EMF, magnitude of EMF, it is 5 pi. Let me explain again. What happened to cos function means, since they are asking maximum value of cos function is 1. Therefore take cos phi equal to 1. Okay. Thereby magnitude of induced EMF is 5 pi. An aircraft with wingspan 40 meter flies with a speed of 1080 km per hour in the eastward direction at a constant altitude in the northern hemisphere, where the vertical component of Earth's magnetic field is given. Then EMF induced between tips of the wings. It is like motional EMF. When aircraft is moving perpendicular to the Earth's magnetic field, there is EMF induced given by BLV. Magnetic field is 1.75 10 power minus 5. Length is 40 meter and speed is given as 1080 km per hour. Kilometer per hour to meter per second means 5 by 18 equal to 300 meter per second. Therefore EMF equal to, so this 300 here, 10 power 2, 10 power 3, 10 power minus 5 is 10 power minus 2. Product of these two is 0.21 volt. In a series LCR at resonance, current and voltage are in phase. Yes. Impedance is maximum, no, minimum. Current is minimum, no, maximum. current leads voltage, they are in phase. A transformer is used to light 100 watt 110 volt lamp from 220 volt mains. So here is a transformer. Okay, call this primary and this coil secondary. At the secondary we have to connect the bulb, isn't it? So 100 watt 110 volt, this is voltage across the secondary. Voltage across the primary is 220 given, and current is 0.5. Current at the primary is 0.5 ampere. We have to find current at the secondary. Power equal to current into voltage. Current is power by voltage. Power is 100 by voltage is 110, which is equal to 10 by 11. This current is current at the secondary. Okay. Now, efficiency of the transformer. Always efficiency equal to output by input. Power at the output. Output is nothing but secondary. Input is primary. Power at the secondary is current into voltage. Current at the secondary, voltage across the secondary, power at the primary. Current of the primary, voltage across the primary, equal to. Current at the secondary is 10 by 11. 10 by 11. Voltage across the secondary is 110 by current at the primary 0.5. Then voltage at the primary 220. This 1, this 2. 2 into 0.5 is 1, which is equal to 10 by 11. This is approximately 0.9. Therefore, efficiency equal to 90%. The average power dissipated by pure inductor or pure capacitor is 0. That is why it is called wattless current. Wattless current. If epsilon naught, mu naught are the permittivity and permeability of free space, epsilon, mu are the corresponding quantities for a medium, then refractive index of the medium. Speed of light is given by 1 by root of mu naught epsilon naught. Similarly, speed of light in a medium is 1 by root of mu epsilon, and refractive index equal to speed of light in vacuum by speed of light in medium, which is equal to 1 by root of mu naught epsilon naught. This is root of mu epsilon. Mu is mu naught into mu r, epsilon naught into epsilon r. This get cancels. This goes to numerator, which is equal to root of mu r epsilon r. Refractive index is root of mu r epsilon r. This is not the answer. Insufficient information? No. We have to decide between these two. This numerator has mu naught mu r epsilon naught epsilon r by denominator is mu naught epsilon naught under root. You simplify, you'll get this. A person wants a real image of his own 3 times enlarged. Where should he stand in front of a concave mirror of radius of curvature? This is a concave mirror, principal axis, concave, focus, center of curvature. This distance is 30 centimeter. To get 3 times enlarged. So magnified real image. To get magnified real image, object should be between F and C. This concept you know. If object between F and C, we get magnified real. Somewhere here, bigger image. Between these two means if this is 30, this should be 15. So the object distance should be between 15 and 30. Find out the values between 15 and 30. It is 20. Calculate focal length of reading glass of a person if his distance of distinct vision is 75. For a normal person, distance of distinct vision should be 25. So 1 by F equal to 1 by F1 plus 1 by F2. 1 by F is 1 by 25. 1 by F1. For his eye, 75 plus 1 by F2. And solve for F2. This F2 turns out to be 37.5. In Young's double slit experiment, the slit separation is 0.5 meter. This is small d. For a monochromatic light of wavelength lambda, distance of third maxima from second minima on the other side. This is the median, screen, central maximum, first maximum, second maximum, third maximum. So this is third maximum on one side. This distance is 3 lambda capital D by small d. How this is obtained? Xn equal to n lambda capital D by small d, n equal to 3. Okay. First maximum, second maximum, this is first minimum, this is second minimum. On the other side means this distance. For a dark fringe, Xn equal to 2n plus 1 into lambda by 2 capital D by small d. For second dark, n equal to 1. Therefore, substitute n1, 2 into 1 plus 1, 3 by 2, 1.5. So this distance is 1.5 lambda capital D by small d. So distance between these two means sum of these two. 4.5 lambda capital D by small d equal to 4.5, 500 nanometer, 5, 10 power minus 7. Capital D is capital D is not given. To observe diffraction, size of the obstacle, no relation to wavelength, wrong. Much larger than that of wavelength, should be of the order of wavelength. In diffraction, it should be of the order of wavelength. The polarizing angle of glass is 57 degree. A ray of light which is incident at this angle will have an angle of refraction as polarizing angle plus angle of refraction equal to 90 degree. This is 57 degree plus angle of refraction 90 degree. Therefore, R should be equal to 33. Light of two different frequencies whose photons have energies 1 eV, 2.5 eV respectively successfully illuminate a metallic surface whose work function is 0.5. Ratio of maximum speeds of emitted electrons will be energy equal to work function plus kinetic energy, which is half m v square. Energy of incident of the first is 1 eV equal to work function is 0.5 eV plus half m v1 square. Second case 2.5. This is 2.5. This is as usual 0.5 work function. Half m v2 square. These two gives 0.5 eV. Half m v1 square. Resultant of these two gives 2 eV. This is half m v2 square. Divide one by the other. Electron volt, this one time, this 4 time. Half m get cancels. Therefore 1 by 4. v1 square v2 square. v1 by v2 equal to, take square root, it is 1 by 2. Find de Broglie wavelength of an electron with kinetic energy 120 electron volt. 120 electron volt means that should be accelerated by a potential difference of 120 volt. And de Broglie wavelength is equal to h by p, h by root of 2me, h by root of 2m. Kinetic energy is charge times potential. If it is electron, then wavelength equal to 1.227 nanometer by root of voltage. So we can use this. This is true only for electron. Okay, please understand, this is only for electron. Equal to 1.2 nanometer approximately by root of applied potential is 120 to get kinetic energy 120 eV. Okay, so this is 120. If it is 121, then square root of 121 is 11. So very close to 11. So it is 1.2 nanometer by 11 equal to 0.12 approximately nanometer. 0.12. We have two options, 112, 124, because these two are approximation of this. This is greater than 10. If this increases means this ratio should decrease. This ratio should decrease means it cannot be 0.12, it is less than 0.12. Less than 0.12 means this. PM. Nano is 10 power minus 9, pico is 10 power minus 12. An alpha particle of energy 5 MeV is scattered through 180 degree by gold nucleus. Scattered 180 degree means if this is gold nucleus, this is alpha, it retraces the path. Okay, here theta equal to 180 degree. The distance of closest approach. Distance of closest approach means alpha particle is a charged particle. Gold nucleus is also charged. If alpha can come up to this and return means there is potential energy. So kinetic energy of the alpha particle should be equal to electrostatic potential energy. 5 mega is 10 power 6. Electron volt to joule means 1.6 10 power minus 19 into potential energy of system of charges, two charges means constant Q1 Q2 by R. Constant is 9 10 power 9. One charge is charge of alpha. Q1 is charge of alpha. It is 2 times 1.6 10 power minus 19. There are 2 protons in alpha. And gold means atomic number is 79. It is 79 times 1.6 10 power minus 19 divided by R. R is the distance between alpha particle and the nucleus, where the potential energy is equal to kinetic energy of alpha. This get cancels with this. Simplify. R turns out to be 10 power minus 14 meter. Don't worry about these numerical values. Just take care of powers. 10 power minus 14 meter is nothing but 10 power minus 12 centimeter. If an electron in hydrogen atom jumps from 3 to 2, then emitted radiation has a frequency. Frequency of radiation is given by Rc into 1 by n1 square minus 1 by n2 square equal to Rydberg's constant, speed of light, 1 by 2 square minus 1 by 3 square. This is 4. 1 by 4 minus 1 by 9 is 5 by 36. Rc 5 by 36. What is the wavelength of light for the least energetic photon emitted by Lyman series? If this is the energy level diagram, when transition takes place to first level, then it is called Lyman series. Least energy means among all these transitions, this is the least. 2 to 1 for least energy wavelength means this is first member of Lyman series. First member of Lyman series is about 121 nanometer, 122 nanometer. If you use the formula, use wavelength 1 by lambda is wave number equal to R into 1 by n1 square minus 1 by n2 square equal to R into 1 by 1 square minus 1 by 2 square. 1 minus 1 by 4 is 3 by 4. Therefore, 1 by lambda equal to 3/4 of R, or lambda equal to 4 by 3 R. Simplify this, you'll get 121 nanometer. A nucleus at rest splits into two nuclear parts having radii in the ratio 1:2. Their velocities are in the ratio. If it splits into two, then momentum remains constant. This is one part, this is second part. Radius of this is R, radius of this is 2R. 1:2, R and 2R. This travels in this direction with velocity v1. This travels in this direction with velocity v2. From the law of conservation of linear momentum, momentum carried by first equal to momentum carried by second. Momentum is mass into velocity, mass into velocity. Their velocities are in the ratio. So v1 by v2 equal to m1 by m2 by m1. v1 m1, a1 v1. Now, density of the nucleus is constant, which is nuclear mass by nuclear volume. Density is constant means these two are directly proportional. Mass is proportional to volume and volume is proportional to R cube. Therefore, this equation becomes v1 by v2, v1 by v2 equal to m2 is R2 cube. v1 is, v2 is proportional to m1, m1 is R1 cube equal to R2 is 2R. So 2R cube by R cube, 8:1. 8:1. Half-life of a radioactive substance is 20 minutes. Half-life is 20 minutes. Time taken between 50% decay to 87.5% decay of the substance will be. Observe these values, they are distinct values. This is for a radioactive substance. Okay. When we start from this, time taken for half of the decay, which is 50%, is 20 minutes. 50% to 75%. So this is another 20 minutes. But this is given as 87.5. 87.5 is somewhere here. So from 57 to 87.5 means it is 20 minutes plus some time. 20 minutes plus some time is 30 minutes. And this is very close to the another half life. Another half life means 2 times 20 minutes is equal to 40 minutes. Less than 40 but much greater than 20 is 30. Use the formula, simplify, then also it turns out to be 30 minutes. A radioactive decay can form an isotope of its original nucleus with the emission of standard question 1 alpha 2 beta. Suppose ZXA is the element. If this emits an alpha particle which is 2He4 plus Z2 is removed means Z minus 2, A4, A minus 4. Let it be element P. With the emission of alpha, atomic number decreases by 2. Now P, Z minus 2, A minus 4 emits a beta particle means beta is minus 1, 0 plus Z minus 2. We should get Z minus 2 minus 1. So this should be Z minus 1. Z minus 1 minus 1 is Z minus 2. This is A minus 4. Atomic mass number remains same. Some other element Q, because Z minus 2, Z plus minus 1. Now if Q emits one more beta, A minus 4, beta minus 1, 0, Z minus 1 means there should be Z, element R, A minus 4, 0, A minus 4. See, atomic number is same, different mass numbers means these two should be isotopes. To be isotopes, there should be emission of 1 alpha and 2 beta. It's a standard result. An LED is constructed from a PN junction based on a certain semiconducting material whose energy gap is 1.9 eV. Then the wavelength of the emitted light is 1.5 eV is for red. 3 eV is for violet. For violet, wavelength is 400 nanometer. Red 800 nanometer. 1.5 eV red. This is 1.9. 1.9 is somewhere here, closer to 1.5. So wavelength should be just less than 800. Less than 800 is 650 nanometer. This is how you can guess based on logic. This is how you can guess based on logic. Okay, and you can also observe distinct values. If you want to solve, energy equal to hc by lambda. This energy is 1.9 into, this is in electron volt. Electron volt to joule means 10 power minus 19. 1.6 10 power minus 19. hc by lambda. So take lambda, simplify. This number is 6.5 10 power minus 7. Nothing but 650 nanometer. Amplitude modulation has, in the revised syllabus, this chapter is removed. The circuit has two oppositely connected ideal diodes in parallel. Which of them is correct? Which of the following is correct? Plus, plus, plus. This is in reverse bias, doesn't conduct, opposes. Opposition is very high, resistance is very high in reverse bias. 12 volt, 4, so this is the direction of current. 437. So current equal to voltage by resistance. Voltage is 12, 4 plus 3. The input characteristics of CE amplifier. Amplifier, revised syllabus, there is no transistor. The given truth table is for 0 into 0, 0, 0 plus 0, 0. So these two are not true. You have to check for NAND gate and NOR gate. Answer is NAND gate. Please check truth table, direct question. The waves used in line of sight communication. 15th chapter out of syllabus, communication chapter.